Hey girls, we're starting a new unit today, so you're going to have to get on Schoology and print out your new notes for Chapter 3 in Unit 2. It's going to be in that folder, Unit 2. Click on that, click on Chapter 3, and you'll see the Chapter 3 notes at the top. Unit 2 is focusing a lot on graphing lines as changing like from tables to equations to graphs and flipping between those different forms of equations of lines. In Unit 1, we were focusing a lot on solving equations and getting the x value by itself. But now we're going to actually look at what does an equation look like if you graph it on a graph. We looked at relations on graphs and relations on tables by just having some different coordinate points in Unit 1. But now we're actually going to have specific equations that we create graphs for. So let's get into it. We're going to only focus on linear equations right now, and we're going to figure out if linear equations are linear or not by putting them in standard form. The definition of a linear equation is any equation that forms a straight line when it's graphed. The standard form for a linear equation looks like this: ax plus by equals c. And this equation has to follow 4 rules. Rule number 1, a has to be a whole number, meaning 0, 1, 2, or 3. It can't be negative and it can't have decimals. Rule number 2 is that b and c have to be integers. So it could be anything like -2, -1, 0, 1, 2. It's kind of like whole numbers, but they can also be negative. Rule number 3 is that a and b cannot both be 0. You can have 0x or 0y, but you can't have both 0x and 0y because that wouldn't make sense. You wouldn't have any variable left in your equation. Finally, rule number 4 is that a, b, and c have to have a greatest common factor of 1. Let's take a look at that specific rule in an example. Let's look at this equation. 2x plus 4y equals 10. It's close to standard form because it has the x term first, then the y term, then the equal sign, then the number. But it's not standard form because a, b, and c, 2, 4, and 10, have a greatest common factor of 2 instead of 1. So if you wanted to fix this equation and put it into standard form, you would have to divide out the greatest common factor of 2. When you divide out a number, you have to divide every term by that number to keep it balanced, just like you would in an equation that you were solving. So if you divide this, 2 divided by 2 makes 1, so you have 1x, which you can just put x. You would get 2y, you'd bring down your equal sign, and then 10 divided by 2 would give you 5. Now this equation is in standard form because the GCF of 1, 2, and 5 is 1. Even though this equation 2x plus 4y equals 10 isn't in standard form, it's still a linear equation. It's just not written in standard form. If you were to graph 2x plus 4y equals 10 on a graph paper and x plus 2y equals 5 on a graph paper, you'll notice they're the exact same line. They're just multiplied or divided by 2, however way you look at it. It's going to be helpful for you to memorize this equation and the 4 rules for standard form because in the test, if it says you have to put this equation in standard form and you don't know the 4 rules for standard form, you're not going to know how to put the equation in standard form. So I would recommend making note cards to help you memorize those rules or doing some type of study strategy that works for you. A couple other notes about standard form. C over here is called the constant because it doesn't have a variable on it, and ax and by are called the variable terms. Let's get a couple more examples of determining whether equations are linear by writing them in standard form. Take a look at this first example, y equals 4 minus 3x. This equation is linear. However, it's not in standard form. To put it in standard form, you're going to have to move the 3x over to the other side. Since it's subtracted on the right side, we'll have to add it to get it over to the left side. 3x and y are not like terms, you'll just leave them separate. 3x plus y, bring down your equal sign, bring down your 4. Now it's in the right form, ax, then by, then equals, then c. So you want your x term first, then your y term, then your equal sign, then your constant term. Now that the terms are in the right order, let's make sure it follows all the rules. Rule number 1, is a whole number? Yes. Rule number 2, b and c are integers? Yes. Rule number 3, a and b are not both 0. We're good. And finally, rule number 4, the GCF of a, b, and c is 1. Since it follows all 4 rules and the terms are in the right order, now it's in standard form, so we know for sure it's definitely a linear equation. Looking at example B, this one, 6x minus xy equals 4, it is not a linear equation because you're never going to have the two variables x and y multiplied together. At first, you might be thinking it's kind of standard form because it has the ax, it has the equals c, but when you look at the middle part where it's supposed to be by, remember b has to be an integer. It can't be xy, it has to be an integer times y. So since that's not an integer, x is a variable which could represent any real number, a fraction, a decimal, or anything. This is not a linear equation. Looking at the practice problems for a couple more examples, we'll look at this one first. 1/3 y equals -1. It is linear, even though it doesn't have an x, we could write that as 0x plus 1/3 y equals -1. Let's go through the rules. I know that a has to be a whole number. 0 is a whole number, so we're good. B and C have to be integers. 1/3 is not an integer. What you can do to fix that is you can multiply by whatever's the number in the denominator. So we'll multiply it by 3. But you can't just multiply the y term by 3. You have to multiply every term by 3. 0 times anything makes 0, so we still have 0x. 1/3 times 3, if you need to go off to the side and write that down, it's like doing 1/3 times 3 over 1. The 3's can reduce by 3, so you end up with 1y. And then on the right side, you get equals -3. Rule number 3 says that A and B cannot both be 0. It's fine to have a 0x as long as you have a number in front of y. And then rule number 4 is that the greatest common factor of A, B, and C is 1. Since it follows all 4 rules and it's in the right order, we know this is in standard form. Finally, this last practice problem is not a linear equation because you can't have a power on the variable. Remember, it's just ax to the first power plus by to the first power equals some constant. You don't have any powers or exponents on your variables. That will make it not a linear equation. A couple more notes for you. On that last problem where we had 1/3 y, 1/3 y equals -1. We said it was linear and it didn't have an x in it. Anytime you have a linear equation without an x in it, or if you have 0x, that is an equation for a horizontal line. Anytime you have a linear equation without a y in it, if it's just ax equals c and it's like a 0y, that's the equation for a vertical line, which, by the way, is the only linear equation that's not a function. Because think about it, a vertical line, it's not going to pass the vertical line test, whereas every other straight line will pass the vertical line test. If an equation has both x and y in it, that's what makes it a slanted line. So just y is horizontal, just x is vertical. If it has x and y, that's when it's slanted. Let's do some more examples of looking at equations and their graphs and putting equations in standard form. It says, write each linear equation in standard form, graph them on a coordinate plane by making a table of at least 3 values. It might be helpful for you to make your background a graph paper here on OneNote by clicking View and going to Rule Lines and changing it to the small or medium-sized grid. That way you can graph all the different equations that we're doing in this chapter on a nice graph paper background. Okay, let's start with this first linear equation. It's a function f of x equals 2 over 5x plus 6. If it helps you, you can rewrite this as y equals 2 over 5x plus 6. Remember, with function notation, f of x is the same thing as y. So if you want to cross that out and put y, it means the exact same thing. This is not in standard form, but we could change it to standard form. We're going to want to move the x term over to the other side by subtracting it. So we have -2/5 x. The y is still positive. Bring down your equal sign. On the right side, you still have your positive 6. This is closer to standard form. The terms are in the right order, but it's already breaking rule 1 that a has to be a whole number. In order to fix that, we can multiply every term by -5. I'm going to use parentheses to make sure I know it's multiplying and not subtracting. You want to make sure that's clear. Then I can go through and multiply it. I know a negative times a negative makes a positive. 5/1 times 2/5 makes 2. So it's 2x -5y equals -30. Now this follows all the rules for standard form, and it's in the right order. Let's say we wanted to graph this on a coordinate plane. You can do that by making a table of values. You can pick any numbers you want to plug in for x, but try to pick wisely so that you can easily multiply these together. It's going to be the easiest to plug it into the original equation since in this form, y is already by itself. So if we plug in 0 for x, which I would always choose a 0 because multiplying 0 by anything always gets you 0. 0 times even a fraction, it's still equal to 0. So that's going to always be an easy number to plug in. 0 plus 6 makes 6. So putting this together, when x is 0, y is 6. So I have a coordinate point at 0, 6. The next x I chose to plug in was a 5. The reason why I chose that one is because I know that I can multiply 2/5 by 5 pretty easily. The 5's can reduce down, so I just get 2/1, or 2 plus 6, which makes 8. So putting the x and y together, 5 and 8 would have to be the coordinate point. Finally, I chose 10 because I know 2/5 is going to be easy to multiply by 10/1. I can reduce down the 5 and 10 to 1 and 2, and then multiply 2 by 2 to get 4. 4 plus 6 makes 10, so I know I have a coordinate point at 10, 10. You're allowed to choose any numbers for x. They can be positive, negative, fractions, whatever you want. It doesn't have to give you whole numbers here. If you get fractions, it doesn't mean you're wrong. You might have just not picked the best number to plug in, but that's okay. Now, typically a table isn't going to have all these columns in it. It's normally just going to have the x and the y like we saw in Unit 1. So let's just make a more simplified table and then drag this table over off onto the side so that we can graph it. Based on what we learned in Unit 1, you should know how to graph these points from a table to a coordinate plane. The difference between Unit 1 and what we're doing now in Unit 2 is that once you get those points individually on the graph, then you're going to want to connect them with a straight line. These aren't just discrete points anymore. This is the graph of a straight line, so we have to connect all the points together. We picked random x's that we thought were good, like 0, 5, and 10, but that doesn't mean those are the only x's on the graph. For example, if you had picked, like, let's say 3, it looks like it would have given you something around 7. That might not be exact because we didn't use algebra to figure that out, but it looks like that's close to where the line is going through. Alright, I want you to try this practice problem, put it in standard form, and then make a graph for the equation. In standard form, your equation looks like this: x plus 2y equals 0. You get that by moving the x term over, and when you do that, you're left with nothing on the right. To represent that, you put a 0, and then to get rid of the fraction, you multiply every term by 2. For the table, you can pick any values you want for x. I would recommend always choosing a 0, and then plug them into your equation. It's going to be easiest to plug this in to the form where the y is already by itself, since you're trying to figure out what y is equal to. So rather than solving it, just plug it in where y is already by itself and get your 3 points. Now I chose 0, 2, and 3. I found out 3 was probably not the smartest to plug in, but I wanted to show you it as an example because then you see if it's a fraction, that doesn't ruin the graph. That's still okay. On the graph, it would look like this. If I plotted those 3 points, I would have the graph that's shown here with the black dots. Now, those aren't the only points. Let's say I had this graph and I wanted to answer what is f of 1. If I wanted to answer that with the graph, it's saying that the x is 1. So I'm going to look on the graph where x is 1 and find the point. It looks like the y is -1/2. So I can say f of 1 equals negative 1/2. All right, a few more examples. Let's talk about linear versus nonlinear again. If I'm looking at all these graphs, remember linear equations are only those that are straight lines on a graph. So the ones that I'm circling here in yellow are the ones that represent a linear equation. There's only 3 of them in these examples. If I wanted to figure out which ones are functions or not, that's where I'm looking at whether or not they pass the vertical line test. So that would be this one, this one, this one. All the top row are all functions. This is a function. This is a function. This is not a function because it wouldn't pass the vertical line test. If you put a vertical line here, it goes through more than one point. Again, this is not passing the vertical line test because if you put a vertical line there, it's definitely passing more than one point. This is a function, and this is a function. Notice all the linear ones are functions except the vertical line. That one's not a function because it doesn't pass the vertical line test.